So good morning, dear guests. Good morning, dear jury. My name is Joachim Tresp. I'm presenting you now the prototype, the autonomous mobile robot platform. At first, I want to introduce you into the team so that you know who's around all the development and all things. From my side, my main business, my profession is product management. So all other stuff, robot stuff, is a wonderful activity, and it's deep development things from my heart. And this is all from our team, our 5 guys. We are all interested in robotics and we are doing it, but we are working as professionals in different topics. The next one is Jean-Christophe. He's a French guy. He's a software developer and he did all the representing on the tablet and on the smartphones. The other one is Bernard. He's the chief developer. He had a lot of startups already done. He's now working as a lecturer in a French high school. The next one is Simon. He developed the hardware, all electronics. And the last one is also Thomas Bertozzi. He's an Italian guy and he's working now in America at the MIT. So we are a mixed troupe. And in addition, I want to mention Sylvia, so she supported us in the marketing. So to the core, to the platform. So it's a platform. That means it's unique for different things. So it's not so easy for me to present you already done solutions on it, but it's available for different things. And I mention it afterwards in the use cases. So the main unique selling propositions for this one, because there are existing a lot of them, is first, it's silent moving. So for us, it was important to move it in the household. For example, if you have a wine cooler on top of it, so you want to have it in a silent way, also in hospitals or restaurants. This was the first one. Second is also the movements. So these are smooth movements. You will see it afterwards. I will do the demo in the place there behind. So you can put wine glasses on top of it and it will not fall down. So this was one of our main unique selling points. The third one is we don't use the ROS. So this is robot operating system. So this is open source. So we tried it, but it didn't work. So you have a lot in the community. They develop, but it's not reliable. And you can't trust them and you can't find a stable environment. So all we did here is a whole own development on a Windows platform. So we use Windows 7 embedded. It's a stable platform. It has to run and it works. All the SLAM, that means the localization and the mapping, is done by ourselves. So it's a programming mainly done by Bernard and the team. We use a specific algorithm. This is called CPE, Continuous Pose Estimation. This uses a lot of compute power, but we could reduce it to use it in real time. So this is also one main unique position. It's our own. We have license for this. We can handle and do, and we can also connect to other Microsoft systems. So if you think on Internet of Things, so you can move our platform also in other cloud systems to develop sensor informations or whatever. So the other one is we wanted an easy handling. So all is done by pushing one button. The signs on the buttons, so they indicate different colors, so you don't see it quite clearly now because of the red floor here, but it indicates different moods of the robot to say it's all okay, or there are problems, or it's running, operating, whatever. All the rest is done by a tablet or a smartphone. We develop it on Android, iOS. And so the next picture shows you. So this is the docking station that's normal to charge up if it's down, but this is nothing specific. So this is the tablet screenshot. And you see it's quite easy. You can see the map he already produced. And this is efficient enough to say you have to go to this point, you have to go to this way. So it's a map which is built up on more than 1,000 meters. It can go as far as we have enough storage. So you can think it could also be a map of an airport a map of a railway station to have bigger environments, and we can import these maps into the system so that he is driving on this specific maps, or we can do the exploration. Exploration means we are pushing the button afterwards here to make explore, and he will explore the environment. This takes some time. It depends, you will see it afterwards if you will join the booth. And this is one of the essential parts to have an easy handling. The robot has an IP, that's nothing new, but we can have different robots as a swarm, and we can handle them with different IPs. They can deliver also different sensor informations, so it's a platform. So it's up to you, dear jury, to find a suitable partner to add these additional components on top of it. But we have the possibility to add additional swarm robots. We can now give specific maximum speed. We can also draw forbidden areas not to drive in the map, or we can also add speed zones to drive lower. So the maximum speed is about 1 meter per second. That seems not much, but if you think 1 meter in a second, so it could be quite fast in a normal environment. Look inside, nothing new. So you see a PC and embedded Windows 7 electronic stuff, but it's all own developed. We have all the license self-done, so it's easy for us to handle this stuff. Now let's go to the use cases. So it's a platform. You can bring a good from one point to the other. These are the main focus use cases. Classical one in logistics, in restaurants, hotels, let's see, also, yes, bars, yeah, that's it, and hospitals. This is classical, and they are already existing. But we have, and I have mentioned you the unique selling propositions with licensing, with precision, the high positioning accuracy. So if we have a map or a surrounding with more than 1,000 meters, so we have small tolerances in an area of lower than 1 centimeter. So this is coming back. This depends on this CPE algorithm. So I think the most interesting use case is the autonomous e-scooter. So if you have, and we are looking for a partner which is producing e-scooters for disabled persons. So we have a lot elder persons, disabled persons in airports. So normally you have to ask at the check-in, I want a person who is bringing me with a wheelchair to another one. So we can have this in the same way as an autonomous transport system. So you can push a button that it comes with a wheelchair and the system included in it and brings you to the gateway wherever you want. It comes back. So this is the same procedure as autonomous cars, autonomous taxis, whatever. But it is in small, and it is in a secured environment in a building. Airports, railway stations. So I wanted to add also an actual article from Nissan, so they are working on it. This is not a system like this. This is only a chair, and this moves in a line. But this is the first aim. Nissan is working. So we have also a system, and therefore it would be wonderful from you as a jury to bring us further, to bring us to business partners, so that we can work on this and finalize this wonderful work. So far, so good. I want to thank you for your interest and for the invitation. If you have any questions, so please.
Thank you. How much weight can it carry, this one?
About 50 to 80 kilograms. So we planned to have also refrigerators on it to bring it to events or wine coolers to bring it around. So it can take about 80 kilos. So I could also sit on it, but I don't want to do it. It's in this case 90 kilo. It's too much.
Okay. Any other questions from the jury?
What kind of hardware do you use? Is that only in PC hardware inside?
Yes.
And what is the cost price?
So you see the SICK LIDAR. So this is the most expensive one, 2,500. The PC inside is a normal high-performance PC. It depends also 1,500 because on the algorithm, and the rest is mechanics. So at the end, it's hardware which costs about 5,000 euro. But this is not the aim to have all the high valuable components. So at the end, you will find also low price laser scanners, LIDARs. So they are available at the moment for 400 euros. Also, the PC is going down. So we think it could be a price tag on about 2,000 euros.
In this slide, it shows the charging. It's
Yes.
contactless charging.
No, it has contacts. So you will see these are the connections, and there are lasers. There's a laser who finds the contacts, and at the end, so he has an adjustment to go direct into contacts. We use contacts because we want to have more currency. If you have a wine cooler or something like this, so they have to have more power.
Yeah.
So it's contact.
Another question.
How is the battery range? How long can it work with
Yes.
one charge?
2 hours. 2 hours. So we have at the moment lead acid. It's heavy. So we could also go to another system. It's 2 times 12 volt, but we can also change lithium, whatever. But it takes 2 hours, and it's charging also in 1 to 2 hours. But it's a prototype, so we can improve it also.
Okay. Then thank you very much.